So section 6.5, modeling with trig functions, is playing around with waves and triangles, and we've already done problems like this. So this section is essentially a review. So here I have a triangle, not drawn to scale. They give me two side lengths, A and C, and I need to figure out what the other two angles are and what the missing side is. Let's give that a shot. And this problem is in degrees. So usually what I try to do is redraw the picture to scale if possible to help me see if I'm on the right path when I'm solving it. So we have A, the vertical length here is 2, and then we have a longer hypotenuse there, 5. It's more than twice as long. So let's draw maybe a baseline. Oops, I want the line tool. Let's try that again. Go. Let's have a baseline to work off of. And then I'm going to have a line, and let's say that right there is 1, 2. And then I want to come 5 off of that. So let's guess 5 is going to be, let's see, 1, 2, that's more like 4, maybe 5 is more like that right there. So if that's 1, that would be 1, 2, 3, 4, maybe it's a little over 5 there, but it's close enough. So let's make believe that's 5. So here's my A equals 2. Here's my right angle. Here's my C equals 5. I need to figure out the length of B here. So we can just use the Pythagorean theorem to figure that out. 2 squared plus B squared equals 5 squared. And so that gives me 4 plus B squared is 25. Subtracting that 4, I get B squared is 21. So B is the square root of 21, technically plus or minus, but I just want a length, so we're going to call it positive. 21 factors as 3 times 7, so that root doesn't reduce, so that would be my exact answer here. But this one wants an approximation. All right, so we'll get an approximation in a second. So it's equal to the square root of 21, and then we'll ask the calculator in a moment what the approximation is. So then we have angle A over here, capital A, angle capital B over there. What do we know about those two angles? Well, we know that those two angles are complementary because I have to add up to 90 degrees or pi over 4, or pi over 2, excuse me, and I have to use degrees here. So I know that angle A plus angle B, let's call them angle A and angle B, have to add up to 90 degrees. So then I need to figure out more information about one of them. Well, we were given A equals 2 and C equals 5. If I focus on angle A here, side A is opposite, and length 5 is the hypotenuse, opposite over hypotenuse. Which trig function is that? That sounds like the sine. So I know that the sine of angle A is opposite over hypotenuse, which is the given values 2 over 5. So now I can find A just by using the inverse sign or arc sign. Angle A has to be the arc sign, 2/5. And to get angle B, I just subtract angle A from 90. So angle B will be 90 minus angle A, or 90 minus the arc sign. And we got to make sure our calculator is in the right mode. Let's get a calculator. And what should we use today? I think I've been using Desmos more often. We'll stick with that today. All right, so things I need to know: that side length B is the square root of 21. Let's get a decimal approximation on that. Might as well label it while I'm here. So to 1 decimal place, I believe it said, that would be what, 4.6. At least 1 decimal place, so I could give more. So let's go with 4.58. I like that better. All right, and let's see, A in degrees, and remember Desmos is in radians, so we got to switch over to degrees or do a conversion. Might as well have the calculator do it for us. And then I know that angle A, I'm going to call it capital A, is equal to the arc sine of 2/5. And so for the degree measure, I get 2 decimal places, 23.58. So this right here is about 23.58. Does that seem reasonable in my picture? Yeah, that looks like less than 30 degrees. My picture isn't perfectly accurate, but it's not too bad. So yeah, I'll buy that. That seems like a reasonable number there. So that's one reason I draw these to the best of my ability to scale to see if the numbers I get seem reasonable. Oh, and I didn't ask myself, does the 4.58, 4.6 seem reasonable? The hypotenuse is the longest side. It's only a little bit longer than side B in my picture here. So yeah, 4.6 just seems pretty reasonable for the side length B if C is 5. All right, so I have numbers that seem reasonable here. I'm going to say this one is about 23.58. And then we just have to see what the remaining amount of degrees from 90 is for that one. So now we just want to know B, or capital B, is 90 minus my answer for A, and I can just call it A because I called it A above. If you didn't do that, then you would have to type 90 minus the arc sine, or maybe you prefer to go function sine inverse 2/5. Oops. And notice I get the same answer either way, 66.42. Which again, that seems reasonable in my picture. So this one right here, 66.42 degrees. And again, write this down, show your work, because on your exam, you're going to need to show work. All right, nailed that sucker. Ooh, crazy pen.